So let's talk a little bit about caching. So caching essentially enables dynamic lookup tables to be created and used within your rules. So some examples of this are, if you're watching IAM rules being used for the first time, or instances being spun up, you can create like trust on first use style rules, which is the one that we'll use in this example. You can also create counters. So if you wanted to keep a count of every IP that I'm logging into our SSO system with. You could use that to determine if there's outliers, things like that, or you could generate allow and deny lists over a period of time, which is really, really cool. And that's a really unique advantage that I think you get with Panther. So actually, the number 3 is really, really useful if you're using OS query as well, because it's really common to look for things over a period of time, and then essentially determine, after you've collected your baseline, is something outside of that or not. So the way that this looks is just basic key value pairs. So we create a unique key, and this all lives in the same table. So there is the chance that you could have collision if you don't do this correctly. So you define your key and then a set of values. They can be string sets, they can be strings, they can be counters, it really doesn't matter. But what we do is we actually ship with a couple of different helpers to get you there. So if you were going to use this in a rule, you would import Panther OSS helpers, or you could do specific functions if you just need one or two. And then if you want to keep track of string sets, there's a couple of different functions we expose. So the first one is get string set. So you would pass it the key name. So for example, like this Panther test admin, unique source IPs, we could pass it that, and then we would get the value back into our rule. We can actually put string set, so we can override it completely. We can add to it essentially appending, or we can clear it and reset it. And the way this is used in a rule, this is a trust on first use assume roll call. So this is essentially will store the first IP address that ever assumed a certain role. And this will allow us to determine if someone else had assumed it. And I believe there's a white paper that one of the security engineers I know named Will Bankston had written about this, so definitely go check that out. It's a really interesting read, but this rule essentially reproduces what he's talking about there to determine if an access key is stolen off of an EC2 instance, which may not even be as big of a deal anymore, just given the changes they've made to the API, but either way. What we're doing here is we're processing the events, we're doing some filtering, we're generating this key that we're using for the lookup, and then we're fetching the current value, and then if it's empty, we're going to add to it. And then the second part down here, this if statement, is actually checking if the IP address that we parsed out is in our list of previously seen IPs, which we actually cached. And if it isn't, then we send an alert. So this is definitely a much more advanced use case, and you can get really, really creative with this. You could also do things where you're always returning false, but you're just storing values in the cache. And then maybe after a day of collecting data, you switch it to where if any value exists outside of that list, then you start sending alerts. So that's what I was alluding to before with workflows like OS query. And if you've worked with that data, you should be familiar with what I'm referring to.